Okay, today we're talking about section 4.5. Actually, this is going to be A. I'm dividing it into two parts. 4.5A, modeling using variation. Make sure you put an A on there. Certain formulas occur so frequently in applied situation, that means in real life, that they are given special names. And the ones that we're going to talk about today are those that are called variation formulas, and they show how one quantity changes in relation to other quantities. Okay, the quantities that we're going to be talking about can vary directly or inversely. And I totally did not spell that correctly. So let's try that again. Inversely. Okay, so we have three different types that we're going to talk about. Really, there are only two different types. There's a very little variation on one of them, but I like these problems. They are straight translation from English to math. It's do you know the definition or not? So today we're doing just equations. Tomorrow we'll get into word problems with them. But these are my I like these word problems better because, like I said, there's really no difference. You either know the definition, know how to translate, or you don't. So let's get to it. The first thing we have is one called direct variation. And it is a situation when you see the words y varies directly as x, that translates in math as y equals k times x. K is a number and is referred to as the constant of variation, sometimes referred to as the constant of proportionality, but more times than not I've seen it as variation. Okay, now a little bit of a twist on that one would be if you have direct variation with powers, and you'll see as I do examples. Okay, doesn't really change. It still says y varies directly as the nth power of x. So you just have this little power on there. So what changes is y equals k times x to a power. And they said nth power, so it would be n. You would see squared would be a power of 2, cubed would be a power of 3, and other than that, they'll use the number. But just so make sure you know that squared equals 2 and cubed equals 3. And the last one that we have is inverse variation. And inverse variation, the statement in English will say y varies inversely as x. And if you see that, k is always, always, always on top, but inversely puts x on the bottom. So direct, notice all three of these, k is on top. Direct, there's no fraction. Inversely, you have a fraction and the second variable goes on the bottom. So let's go do that, do some examples. Y varies directly as x, that's what we just had. So I'm going to write y varies directly as x. Now they're always going to give you an example of an x and a y. And what you're going to do with that, y is 45, so I'm going to plug in 45. I don't know what k is, and x is 5. So as we just learned, we divide both sides by 5 to solve that, and we find out that 45 divided by 5 is 9 is equal to k. So the true equation is y equals 9 times x, because now instead of k, k was equal to 9, so I plugged in 9 for k into that formula. So this equation deals directly with this problem. Now it says find y when x is 13. So what is y when x is 13? So multiply that out on your calculator and you will find that y equals 117. Okay, let's look at the next one. The next one says y varies inversely as x. So my definitions, if I have inversely, then k is on the top and whatever came after it is on the bottom. Okay, and again, they're going to give you some numbers to plug in. y equals 20 when x equals 25. So y is 20 when x is 25. So this says that 20 equals k over the square root of 25, which is 5. So as we have done before, I'm going to multiply both sides by 5. This bracket is preventing me from writing 5 on both sides of the equation. If you don't want to put the brackets, you need to put 5 on both sides of your equation. Okay, so I find out that 20 times 5 is 100. So my equation specific to this problem is y equals 100 over the square root of x. Now again, find y when x is 4. So what is y when x is 4? So I'm going to put in 4 for x, and 100 divided by the square root of 4. Square root of 4 is 2. 100 divided by 2 is 50. So we're good. All right, so we can combine and put both of those in the same equation, and this is what it looks like. It says a varies directly as b and inversely as the square of c. So I have directly and inversely in the same sentence. So a, if I have inversely at all, I'm going to have a fraction. K is always on top. Directly, what comes after directly goes on top. What comes after inversely goes on bottom. It is the square of c. C squared. Remember we talked about the square means 2 and cube means 3. So a equals 7, as I said before. They're always going to give you the numbers so that you can plug it in. So we know that a equals 7 when b equals 9 and c equals 6. So a is 7 when, I don't know what k is, but b is 9 and c is 6. So I plugged them in as such. Now, I'm going to tell you, this will hold true every single time, okay? Because this is all multiplication. So if you have two of them at once, to get rid of that 6 squared, I have to multiply. To get rid of the 9, I'm going to have to divide. So that means that k is going to equal 7 times 6 squared over 9. Now, you can always write it on both sides if you want. 6 squared over 9. You'll see that these two cancel, okay? And then that's why I get 7 times 6 squared over 9. So when I solve that for k, I'm going to find out that k is equal to 28. So my equation is going to say a equals 28 times b over c squared. And they are asking me to find a, so I'm looking for a, when b is 4 and c is 8. So we put that in and square it. Now, we've talked about parentheses aren't critical unless you have a negative number, so either way how you want to do that. When you plug that in, okay, no decimals, okay? Unless they're decimals in your original problem, don't give me a decimal. This answer is 7 over 4. So a equals 7 over 4. Okay, one last problem. Turn to the back of your note sheet, and if you look, I came down here to number 30. This doesn't have any numbers in it, but I want to just do the example so you'll know how to do these other three. Write an equation that expresses each relationship, then solve the equation for y. X squared varies directly as y. Okay, the first variable mentioned equals, you're always going to have a k, and directly means it's multiplication, and then the next variable. And then I have to solve it for y. So to solve this for y, this is multiplication. I'm going to divide both sides by k. And so that tells me that that's not what I wanted. Go away. Ah, k. K. X squared over k equals y. So I translated and then I just solved it for y. So you're just getting some extra practice in solving that equation. Okay, I'm done. I want you to go back at the beginning under the inverse and write squared equals 2 and cubed equals 3, and then bring me your note sheet. And while you work problems, come see me if you have any questions. Thanks.